Hi and welcome to MSc. In this video we're going to be looking at the unit circle, specifically the angles and coordinates on the unit circle. So once you've had a chance to look at special angles and angles in standard position, then the next step is usually looking at the unit circle and using it as a memory aid to not just remember the special angles that were discussed in an earlier video on two triangles and the trig ratios that come from it, but also branching that out, covering an entire circle, and then by extension, multiple loops around a circle, we can also use this system for as well. So the unit circle, which you probably have seen in some rendition, generally looks like this, and we have terminal points at the end of each of these spokes. And those terminal points are t, and they're actually r times cos theta. Cos is always the x coordinate, and r sine theta. And we have to remember that when we're talking about the unit circle, though, the r, the radius of this length, is 1, right? So this length here has an r of 1. And so we're actually talking about the coordinates not being r cos theta, but just cos theta. And we can scale this for different size circles and trace out points around a circle of any size. In this, we are assuming that this is put on a Cartesian plane, and you have your x-axis running horizontally here. This will be your x-axis, and this would be your y-axis running vertically with your origin here in the middle. Okay, and so we have this broken up into different degrees. Let's look at quadrant 1, which is this quadrant on the unit circle here. So this is quad 1 here. So if we look at the angles along here, well, obviously this is 0 degrees here. These are broken into angles of 30 degrees, and those are part of the special angles that you would have seen already. This is 45, and this is 60 degrees. Okay, and then we get around to 90 degrees. So I will complete this for all the angles in a moment, but let's look at these points along the unit circle. And because it is a circle of radius 1, the coordinate here is 1, 0, right? The x value has a value of 1 and the y has 0, or you can say that cosine of 0 is 1 and sine of 0 is 0. At the top here, we are 0 in the x and we're 1 in the y. Right? And you can just see that from an xy grid if it's a unit circle with radius 1, but we can also say that now cosine of 90 is 0 and sine of 90 is 1. Then we have the other coordinate points, and we know sine and cosine of 30 degrees from the special triangles. Cos of 30 degrees is root 3 over 2. And sine of 30 degrees is a half. The next coordinate along the way is 45, and this comes from that isosceles triangle, the right isosceles triangle, and this, they're both the same. We have root 2 over 2, and we have root 2 over 2. And then at 60 degrees, if you remember, it swaps the coordinates here. Sine becomes the value of cos and vice versa. So in this case, cos of 60 is 1/2, and sine of 60 is root 3 over 2. So now we've completed the first quadrant here for degrees and for our coordinates. Okay, and this all comes from those special triangles. This does take some memory work to work through. If we're continuing on with the angles here, we can see that we keep adding these groups of 30, and then we have these other ones that are all like kind of the 45s, 45, 90, and so on. So I'll go through and quickly number these, going by the 30s first. So 120, 150, this is 180, and then we have 210, we have 240, 270, 300, 330, and then 360. When we come all the way back around. Additionally, we have the 45 added to this, which is 135, and 45 added to this, which is 225, and 45 added here, which is 315. Okay, now we have to figure out the other coordinates. Now at this point you should have seen angles in standard position. I have a video on that I'd check out as well. And we understand, hopefully, that we have reference angles that we can use to help us relate these other angles back to our standard angles. So for example, here at 120, I have a reference angle of phi, and it's a reference angle of 60, which means the size of the cosine and sine of 120 are the same, 1/2 and √3/2. What's different is because we're in quadrant 2 now, quad 2, we have a different part of the cast rule. If you remember that we had cosine's positive here, everything's positive in quadrant 1, sine is positive in quadrant 2, and in quadrant 3 we have tangent being positive. So the sine will be positive in this case, but the cosine will be negative. So this angle here that relates to 60 is this, except we will have a negative 1/2 because the cosine, which is the x-coordinate of 120, is negative, and then we'll have positive √3/2. This also works very well if you remember that this is on the xy plane. And of course the x value will be positive here, the x value will be negative here, but the y value will be positive. So that will lead to a little bit less confusion when writing these out, remembering that the x will be negative. So this has a reference angle of 45, so it will be √2/2, but the cosine will be negative because of course the x value is negative here. And then this one will be the √3/2 and 1/2, but it will be negative √3/2 and 1/2. This point, like this point, are just points on like the x and y axes respectively. So this will be -1, 0, and this one down here will be 0, -1. Okay, I'm going to go a little quicker through the last few that we have left. Okay, well, again, in this case we have a reference angle of 30. It will be the same as this, so we could say, okay, well, this is going to be negative √3/2. It's negative because, of course, we're negative in the x. Cosine of 210 is the same as cosine of 30, as it happens to be negative. And then we have negative 1/2. And we'll see as we go down here that all of these are negative because, of course, I'm negative x and negative y in this quadrant. Additionally, we have cosine and sine are both negative in quadrant 3. So here we have negative √2/2, and we have negative √2/2, and then here, well, I'll close the bracket, and then here I'm running a little tight on space. We have negative ½ right? Because we have a reference angle here that is 60 degrees, and that will generate a cosine of 1/2. So it's negative 1/2 and negative √3/2. Another way you can tell that the cosine has to be the half here is if we think about where we are in the circle, the x value here is approximately halfway across. Well, it should be exactly halfway. I just eyeballed it, right? Whereas here, the y value should be a half because this should be halfway down that y-axis. So remembering where you are on the grid, on an xy plane, can help you realize that that one has to be the half. It can help you memorize whether it's the x or y, and thus the cos or sine functions that are the half values. So here you can clearly see I'm halfway across, so the value here will be 1/2, and it would be √3/2. That will be the negative there, and you can see I'm negative because I'm negative y, the positive x, cosine's positive, so my x-coordinate will be positive here. This will be √2/2 and negative √2/2, and this last one here is going to be √3/2 and negative 1/2. So using your first quadrant and your knowledge of those special angles, you're able to, with reference angles, complete the rest. Ideally, if you can memorize this and be able to write it out in quick order, then it will help you to quickly pull on information for angles that you might not have otherwise thought you could do without a calculator. Remembering, of course, that you have different quadrants. Here's quadrant 3 and quadrant 4, where there's different signage required. And that's not surprising because you know how the x and y values work, but those relate to sine and cos, and the cast rule, which I also have a video on, which I'd encourage you to look at. I hope this run through of angles and coordinates in the unit circle has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.